Hi everyone. Good morning. Uh, this is Dr. Shirish Kiriru again. Till now, we have seen the working and other details of boilers as well as mountings and accessories. We'll move on to discuss another interesting topic that is about water turbines. Now, water turbines are also called as hydraulic turbines, and uh, while we were discussing IC engines, I had already mentioned about prime movers, which are basically devices that convert some form of energy into mechanical energy, and this mechanical energy is finally used to either run a turbine or for the purpose of locomotion. So hydraulic turbines or water turbines are also a form of prime movers, and basically they use the energy contained by the water in order to run a turbine. Now, just running a turbine is of no use because you just have a shaft which is rotating. So what needs to be done is this shaft of the turbine, which comes out of the turbine, is normally coupled to the shaft of a generator, and finally electricity is produced. So the entire assembly, that is why it is called as a power plant. We have a power plant. Uh, Hydraulic turbines normally they convert the potential energy of water into the kinetic energy, and in order to run a water turbine, normally you need a large mass of water, huge volume of water. So this huge volume of water or quantity of water is generally made available by constructing barriers across rivers, that is dams and so on. Now, the water turbines are normally divided or classified into two types. One is called as the impulse turbine, the other one is called as a reaction turbine. Now, impulse turbine, as the name itself suggests, impulse is a large force which is going to act. Uh, so, impulse turbines are those where all the potential energy of contained by the water is converted into kinetic energy, and this water in the form of a jet is going to impinge or hit the buckets or the veins, and this causes the entire circular disc to rotate. Now we know that whenever we construct a dam across a river, the amount of water which is accumulated is huge, massive, and a very, very high column of water is made available. So from the bed, the total height of the water column may run into meters together, or sometimes even about a kilometer. So the potential energy contained by this water is normally given by rho gh, where rho is the density of water, g is the gravitational force, and h is the column of water. Now, from this bed, there are large pipes which are drawn and taken down deep down further, and it is below or beneath where these water turbines are normally installed. So, by the time the water starts flowing through these pipes, this potential energy gets converted into kinetic energy, and this kinetic energy generally is represented as half mv square. So, since the where m is the mass and v is the velocity, since this water travels at a tremendous velocity, and it is proportional to the square of the velocity, the kinetic energy available at the end of the pipe will be very large. And normally these pipes which carry water from the dams till the turbines, they are called as penstocks. Now, what happens is, in case of a reaction turbine, the head of water that is needed is not as large as what is needed in impulse turbines. So, we have a medium head turbine, such as a Francis turbine, and a slightly low head turbine, which is a Kaplan turbine. Now, even though we say it is medium head, the head needed will be at least a minimum of about 500 meters for a Francis turbine, and for a Kaplan turbine, you need about 300 meters or at least 400 meters head of water. Now, in impulse turbine, a typical example of an impulse turbine is a Pelton wheel. We call it as a Pelton wheel. You will understand why it is called as a wheel, because instead of calling it as a turbine, we call it as a Pelton wheel. There is a central wheel which is rotating. So here you can see the construction of a Pelton wheel or a Pelton turbine. Now we can see that there is a penstock, and penstock is the one which gets water from the dam in this direction, and it passes through and it hits the buckets. So here you are seeing all around the circumference. Okay, so what we have are the buckets, and this is the shape of a bucket, and you can see that a single bucket is made up of two cups, and these two cups are separated by a ridge in between. This is called as the ridge in between. Now when water starts flowing, it comes and hits the bucket. So when the jet of water hits the ridge, it is uh, actually diverted into two parts. That is, this jet is broken into two parts. One part of the water flows in this direction, the other part of the water flows in this direction, and generally what happens is, when you resolve the forces in this direction and this direction will get cancelled, and there is only one force which is finally going to act in this direction on both the cups. So that will make the whole thing rotate in this direction. Okay, so this is a circumferential wheel on which buckets are mounted, and there is a central shaft on which the circumferential wheel itself exists, and as water impinges or hits these buckets, it is going to rotate. The water after hitting the buckets is just made to drop into the tailstock, and it is just taken away. So this water can be used for other purposes like agricultural purpose and so on. Now, since the amount of water is massive, huge, which comes through the penstock, there will be a lot of splashing around, because of which this entire assembly is caged inside a housing. We call this as the housing. Now, generally what happens is, because this shaft is coupled to a generator, and the generator is producing electricity, and this electricity is being distributed to various places. The load keeps on varying. The electric load keeps on varying. Now, if the electric load keeps on varying, the speed of the turbine also changes, but we expect the turbine and the generator to rotate at a constant speed. So, suppose if the load increases, then the speed of this turbine decreases. So, how do we increase the speed of the turbine? By allowing more water. So, conversely, what happens is, if the speed of the turbine increases, then we have to reduce the speed of the turbine. This entire thing is achieved by what we call as a spear. Okay, so this is called as a spear, and this spear is exactly taken to the mouth of the nozzle. Okay, so nozzle is that opening through which the water coming from the penstock is going to come out. So the spear is again, it can be moved in the forward direction or in the reverse direction using a hand wheel. There is a hand wheel here, so you can rotate the hand wheel. By rotating the hand wheel, you can either take this in the forward direction or you can take it back. Now, obviously, what it means is, the shape of the sphere and the shape of the nozzle is approximately the same. So by turning the hand wheel, you can either completely close the outlet or you can completely open the outlet or the nozzle. When you completely open it, a large amount of water is going to flow, and when you close it, no water flows through it. Now, this entire assembly is mounted on bearings, and during times of maintenance, for example, uh, this entire circumferential wheel, that is the one which is rotating, you need to bring it to a halt. Generally, what happens is, uh, because of the bearings and large momentum, see, you cannot imagine each of these cups, what I have shown here. This cup, they weigh each one. So you can see there are so many here. There are maybe about 20-25 cups around the circumference. Now each cup itself weighs about 150 to 200 kgs. Well, so you can imagine what will be the total weight of this circumferential wheel. So it actually acts like a flywheel, and even if there is no water coming and hitting this when it is rotating, it may take maybe a lot of time, hours together, to come to rest. So in order to ensure that for the purpose of maintenance we bring it to halt as quickly as possible, there is a braking jet. Okay, so water is stopped flowing from the penstock, and water is allowed to flow through the braking jet. Now this braking jet will hit the water at the back of the, that is on this side of the bucket. So if it is now in the current construction, we can easily see that the entire assembly is going to rotate in the anti-clockwise direction, in this direction. So once we stop the flow of water and allow water through the braking jet, this braking jet is going to impinge or make the water hit on the back side of the bucket. That is, it is going to oppose the actual motion of the rotating circumferential wheel, so that it will bring it to a halt as quickly as possible. Okay, so you can see how this assembly is, and this is a real Pelton wheel where buckets are mounted. You can see how massive or how big it is in size, and you have to use very good fixtures, large nuts and bolts, in order to mount these buckets onto the circumferential wheel. And this is the shaft. Okay, so this is the shaft, and once this rotates, the shaft also rotates. This shaft will be coupled to the generator, and once this rotates, the generator shaft rotates, and electricity is going to be produced. So this is the schematic representation, and this is the actual picture of the entire assembly. So this the working I have just explained, where how exactly the Pelton wheel rotates, and what is the purpose of a needle. Now in the previous slide we have seen the spear. This spear is also sometimes called as a needle. Okay, and you have a support, you have a stopper. The function of a stopper is, whenever the hand wheel is kept in a particular position, there is so much of vibration that the hand wheel by itself may start rotating in either direction. So in order to hold it in that place, you have a stopper. Okay, then we have it requires very high head. What we mean by high head is, in that formula rho gh, that value of h has to be very high, and it requires considerable amount of water. The water from the high head source is supplied to the nozzle. Now this is done by using what we call as penstocks, and there is a needle which controls the quantity of flowing out of the nozzle. The pressure energy is converted into velocity energy, or we can say that the potential energy is converted into kinetic energy. Then the impulsive force of the jet striking on the Pelton cups or the buckets sets the Pelton wheel to rotate in the direction of the impinging jet, and the entire thing starts rotating. So this is all about the Pelton wheel, and we are going to study about a Francis turbine and Kaplan turbine in the next class. I will also there is an animated video which explains the working of a Pelton wheel. I will also be posting that later. Okay, so thank you very much, and if you have any queries, you can always message me or call me back. Thank you.